Okay, I'm going to try and add some clarification to what is going on example 4b that makes us need to add 180 degrees because we are finding the inverse cotangent given the value that's negative by using the inverse tangent of a negative value. So it starts by really thinking about what is going on with our range. Really is what we're concerned about for all of our functions. I do want to point out, so keep in mind domain, that means what I'm allowed to put in for x. So my domain for all of the first four functions, inverse sine, inverse cosine, inverse tangent, and inverse cotangent, my domain is continuous. I do not have any breaks. I don't have to use the u to join two intervals together. On the inverse secant and the inverse cosecant, I have to join these two unions together. I had no hope of having a continuous interval in my range for the inverse secant and the inverse cosecant. But for all the others, because it's continuous over the the domain is continuous, then I could try to make sure that my range was going to be continuous. And for the first three, that's an easy thing to achieve. For this one, we had to kind of step out and switch it up and not just let it be the same ending points as the range on the inverse tangent, the reciprocal function. So let's look up here at the functions. Again, this inverse secant, the inverse cosecant weren't going to be continuous anyway. And so to make a complete picture, to make a complete graph of what's going to happen for both the negative values we can put in and the positive values we can put into our function for x, we could keep the same numbers on the end for our inverse secant as what we had for our inverse cosine. And we could keep the same ending points in our intervals for the inverse cosecant as we had for the inverse sine. Here's the range for the inverse secant, and it ends at 0 and it ends at pi, and we just have to pick up our pencil long enough because of the asymptote that we have at y equals pi over 2. And down here, the ends are at 0 and pi. So we have the same ends that we have in both of these functions, same ends. Same thing happened over at cosecant. They both begin at negative pi over 2 and end at pi over 2. In the case of the cosecant, inverse cosecant, we have to pick up our pencil at 0 because there's this asymptote in there, but otherwise they have the same ending values. On the other hand, when it comes to the inverse cotangent, the range on the inverse cotangent is running from 0 to pi, and the range of the inverse tangent of x is going to be from negative pi over 2 to pi over 2. They do not have the same ending numbers at all. Oh no, what happened? Okay, it stopped, I don't know, but we're back now. They do not have the same beginning and ending numbers at all. And so that is what is causing us to have to change. Here is where we would see our graph if we chose to keep the two graphs the same. This is where, to go from negative pi over 2 to pi over 2, we would have this piece instead of that piece if we chose to keep our range the same. But if we choose to keep our range the same, now we have to break up the range because of the asymptote that would exist inside there. So by choosing to use a different range for the inverse cotangent than what we have for the inverse tangent, we do not have to break up the function. We can let it be continuous over both the domain and the range. It is continuous over the entire domain by choosing to change the range from 0 to pi. We can show what happens when we plug in negative values and positive values just by being okay with moving it up. Now let's notice too that our x values are going to be the same whether we were here or here. The difference is 180 degrees, adding 180 degrees, or pi. I am pi higher up here than I was down here. That's why we're adding that pi, to make it up here in quadrant 2 so that we can be continuous. This is where quadrant 4 would be, down here. I would have y values down here for quadrant 4, and I have y values from pi over 2 to pi when I'm in quadrant 2. And so I'm talking about the y values on this number line. That is why we shifted it up. We shifted it up from 0 to pi so that we could keep it as a continuous function and not have to have an asymptote interfering with the range for our inverse cotangent. Let's look at the graph quickly just to see what that looks like on the graph. So I have shown the tangent values on this unit circle, not graph, on this unit circle. Tangent values are the ones that are underlined, and so I've put the tangent values that are down here. When I have a negative value, when I get a negative value for my tangent, my inverse tangent is going to give me a value down here in quadrant 4. When I have a negative value for my inverse cotangent, I'm going to be up here in quadrant 2. Notice that the reference angle that goes along with it. Here I have negative square root of 3 over 3. My reference angle to get me to 330 would have been a negative 30 if I was in the world of degrees. And over here, in this one, I still have that same reference angle of 30 degrees. I'm just up here in quadrant 2, but they both have the same tangent. And so both of these angles, 330 and 150, or negative 30, think of this as being negative 30 right here, because that's the way it's going to give it to you when you're using inverse tangent. Negative 30 and 150 both have the same reference angle of 30 degrees. One of them is in quadrant 4. That's where our inverse tangent answers are going to come out to be on negative values going into it. And the other one is in quadrant 2, which is where inverse cotangent answers need to come out to be when we put negative values in it. I hope that's more clear. That's the best I can do to explain why it is that we add the 180 degrees. It's so we can move from quadrant 4, negative values in quadrant 4, negative angle values in quadrant 4, to angle values in quadrant 2.